Hello everyone and welcome to this business calculus class from the University of Utah, fall 2020. In this video we will introduce the concept of the limit of a function. Essentially, the limit of a function allows us to study the behavior of a function as x approaches certain value. I know that might sound a bit mysterious or confusing, so let's look to an example. So in this case, we're asked to explore the function f of x equals x squared minus 4 divided by x minus 2 as x gets close to 2. So the first thing to notice is that if we plug in 2 in our function, the denominator is equal to 0. So in this case, we say that 2 is not in the domain of the function. Okay, so we need to explore this function not using x equals to 2, but using values closer and closer to 2. So we can fill these tables that I have here. So for example, when x is equal to 1.5, you can use a calculator or your computer to evaluate this. You will get that it's 3.5. And you can keep filling this table and you should get something like this. And now you can do the same thing, but with values getting closer and closer to 2, but now from above. Notice that all these values are smaller than 2 and they're getting closer and closer to 2. And now we can do the same thing with values that are getting closer and closer to 2, but from above. So in this case, the values we will get are the following. Okay, so we can notice that even though the function is not defined at x equals 2, we can see that as x gets closer and closer to 2, the value of the function gets closer and closer to 4. Okay, so let's see what we mean with this graphically. Using a graphing device, for example, your computer or a graphing calculator, if you have one of those, you can find the graph of this function, which I plotted here in this slide. So in this case, we can see what is going on by looking at the graph of this function. So notice first of all that we have this hole. So that means that the function is not defined at x equals 2. But if I get closer and closer to 2 from the left or from the right, the value of the function gets closer and closer to 4. That is what we saw previously using these tables, and now we can see this graphically. Now you might argue, okay, but I don't want to be all this semester doing tables or graphing functions. So is there another way to do this? And the answer is yes. And now we will see an algebraically approach of this. As we mentioned at the beginning of the video, x equals 2 is not in the domain of the function. So we cannot plug that value inside the function. But let's see a trick that might allow us to see what is going on when x is closer and closer to 2 as we want. So first notice that the expression on top of the fraction can be factored. So in this case, you would be tempted to go ahead and simplify these things. But the problem is that when x is equal to 2, that means that we're dividing by 0, and we cannot do that. But if we set that x is not equal to 2, then we can simplify these expressions. So now when x is not equal to 2, our function is equal to x plus 2, which is exactly the line that we saw in the previous slide. So in this case, we know that as x gets closer to 2, and we denote this by these arrows, and we will be using them quite frequently, the value of f of x gets closer and closer to 4. So now we're ready to give the first definition of this class. So in this definition of the limit of a function, we summarize what we've been doing throughout this first video. So we will write this, and the way of reading this expression is the limit of f of x as x approaches a equals L. And we can say this when we can make the values of f of x as close to L as we like by taking x to be sufficiently close to a, which is what we did here, where L was equals to 4 and a was equal to 2. And we took values closer and closer to 2, but the main condition is that we don't take the value exactly equal to a. So remember, in this video, we never use the value 2 when evaluating the function. We take values close enough to 2, but never the same value as we're trying to see what is going on with the function. So in this case, throughout this video, we computed that the limit of this function x squared minus 4 divided x minus 2 as x approaches 2 is equal to 4.